So here we have a sine rule example that also uses bearings. So we're told OP initially walks due north for 10 kilometers from a base camp. He then turns on a bearing of 130 and continues walking. After a while he realizes that he needs to return home because it's getting late, and he is now 17 kilometers from base camp. What angle will OP need to turn through to return to camp? Well, we know that he starts off going north. So let's put his base camp just here. And he goes 10 kilometers north to this point here. He then goes on a bearing of 130. Well, clockwise from north, 130 would make him walking in this sort of direction. And we don't know how far he goes along there, but we just know that this angle here is 130, and that means that this angle here is going to be 50 because the angles on a straight line add up to 180. What we do know, however, is that he is now 17 kilometers from the base camp. So if we're looking at the angle he needs to turn, remember he's walking this way and then he needs to walk that way. So he actually needs to turn this angle here and work this one out, and that will give us that one. So, well, actually, we can probably just give the acute angle that he turns. Let's not worry about around the outside. So, I'm trying to find this one, so I'm going to call it A. That's an angle, so I should call it capital A. Then the side opposite is small a. And then I'll call this one B, and this one's B. And what do we get? A over sine A is equal to B over sine B. Substitute in what we know, so we've got 10 over sine, let's call it X, and that's going to be 17 over sine 50, and I'm going to use the activity, and I'm already on that activity, so that's quite nice. So this one, A is 10, big A is what we're trying to find, B is 17, and big B is 50, and then we'll solve, and it gives us 25.78. So X is equal to 25.78 degrees, correct 2 decimal places.